Hi guys, it's Miss McDowell here. I'm going to be doing your dividing whole numbers by decimals, your first lesson with that. All right, so I'm not going to do the warm up here, but I've also just posted the slides without the screencast in case you want to try the warm up for the retrieval process on your own. And then I'll also post a video of me just solving some different whole numbers divided by decimals problems, like in real time. But I thought the screencast with the slides might help some of you. All right, so beginning with the end in mind, today what we're going to do is use visual models as well as standard algorithms to think about solving whole number by decimal problems. And this is all so that we can have multiple methods to solve decimal division problems, as well as conceptually understand how to divide decimals. And so that's what we want our goal to be at the end of this, that we understand two possible methods that we can use to divide whole numbers by decimals. All right, so here we have the problem 2 divided by 4/10. Remember, your dividend, the number you're dividing into, goes first. So 2 is our number that we're dividing into, and we're dividing that by our divisor of 4/10. And so just remember, you're dividing the whole number by decimals for right now. Later on, we will do decimal by whole number, but right now, all your whole numbers should be your dividend, and your decimal should be your divisor, because you're dividing into that dividend with that divisor of a decimal. So here I drew 2 holes. I went ahead because we are going to be dividing this by 10th, and I split my holes into like sections of tenths or even sections of hundredths, just in case we needed to see that. So what you're going to see next is me trying to solve it. So just remember, I'm splitting up my dividend of 2 into equal groups of my divisor of 4/10. So here I just went through my 2 holes and I split them into tenths. So I have, into 4/10 sections. So I have 1/10, 2/10, 3/10, 4/10 in this section. And then I did it again, and I did it with a new color. You could also choose to like shade your hundredths grids. It was just easier for me to just show you with the boxing. So now I have another 10th, 2/10, 3/10, 4/10, and then here I only have 2/10 left in this hole. But I kept it the same color when I went over to the next hole. And so I have my 3/10 and my 4/10 here, which this just represents one part. It's just split between 2 sections, which is okay. And then for yellow, 1/10, 2/10, 3/10, 4/10, and then pink, 1/10, 2/10, 3/10, 4/10. And again, I just needed to, now all I need to do is count up how many particular 4/10 sections I have in this 2 holes, because remember I was splitting 2 holes by 4/10. So how many little chunks of 4/10 do I have in these 2 holes? Well, if you just count your parts, I have 1 here, 2, 3. Remember, this counts as 1 because this makes 2/10 plus 2/10 equals 4/10. 4, 5. So my answer to this particular problem should be 5. I know it might feel a little bit weird that we started with the whole number 2, but remember 4/10 is a lot smaller than 2, and so there should be a lot of 4/10 little chunks in the whole number 2, much like if we took the whole number 2 and divided it by the fraction 4/10 when we talked about doing that. So that's why 5 is bigger than either of the 2 numbers you were either dividing into or by. All right, this is just another kind of way to look at it. So now I have 3 holes, and I'm splitting those into 25 hundredths, okay? Or I'm dividing 3 holes by 25 hundredths. So I have my 3 holes here, but kind of like what I did before, I kind of know that I need to split that into more usable parts. And so I have 1 hole here because it's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. Same here, my second hole of 10/10 and my third hole of 10/10. This one's just split into 2 rows of 5, or 2 rows of 5. All right, so our divisor is 25 hundredths, so we need to make groups of 25 hundredths. However, I don't see anything split here into hundredths, so you're going to see what I'm going to do to kind of make that usable. So what I did is I took one of my tenths and I split it into 10 hundredths, okay? Thinking about my tenths, remember 10 over 10 would still be equal to 1 whole, or like 10 tenths is equal to 100 hundredths. So I need to exchange 1/10 to get my 10 little hundredths, so we can make groups of 2 tenths and then 5 hundredths, okay? So this is what that would look like. These my groups would be, here's my 1/10, 2 tenths, and then 1, 2, 3, 4, 5, my 5 hundredths all added together to equal 25 hundredths. And I just need to keep doing that until I have no more parts left over here. Okay, and remember, just taking 2 rods and then splitting the third rod into half gives you that 25 hundredths. All right, so now all I need to do is figure out how many groups of those 25 hundredths were in the whole number 3. Well, I just go through and count. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 25 hundredths groups in the whole number 3. Remember, 25 hundredths is a lot smaller than 3, and so there should be a ton of little 25 hundredths groups in the whole number 3. You can also kind of connect this to when we did fractions, 3 divided by 1/4. Well, that is 12, because you know that 25 hundredths is equal to 1/4, or if you have 25 cents, you only have 1/4 of a dollar. All right, so now I'm just going to kind of walk you through standard algorithm real quick. So this one is the same one we just did, but how would it look different if we were doing standard algorithm? So what happens here is we set it up like a normal problem, and I'm going to show you this in a separate video that might kind of help with this, but we set it up like a normal problem. So I'm literally I have my 3 in my little house because that's what I'm dividing into, and I'm dividing by 25 hundredths. But you notice my decimals have disappeared. They haven't disappeared, I've just repurposed them. I don't know my facts of 25 hundredths. Those aren't as equal or as easy for me to think of as my facts of 2 or my facts of 4 or my facts of whole numbers. So I need to make this number usable. So what I did is I shifted my decimal out twice to make 25 whole. I know my facts of 25, okay? What I'm really doing there each time I'm shifting it out, remember, is times 10 times 10. All right, so I can't do that to the outside number. I can't do that to the divisor and not do anything to my dividend, okay? I need to make sure I multiply that by the same amount. So I moved my decimal out, and I moved my decimal out times 10 times 10. What you're really doing here is multiplying each of them by 100. 25 hundredths times 100 is going to give me 25. 3 times 100 will give me 300. So now they are both equivalent. Now I can think, how many times can 25 go into 3? It can't. I represented that with a 0 if you need to. You can also just leave it blank. How many times can 25 go into 30? It can go in once. 1 times 25 gives me 25. I subtract, I'm left over with 5. I'm not done yet though, because I still have my 0 that I have to carry down. How many times can 25 go into 50? It can go in twice. 2 times 25 is 50, and I have none left over. My answer still gives me 12. All right, we are going to look at one more together like this, and then we will stop there for the screencast, okay? So here I have 4 divided by 8 tenths. All I did was draw 4 holes. This time I drew it in my hundredths grid. I think that these tend to be a little bit easier to see maybe than the separate rods and units. So here again, I'm just separating out 8 tenths out of my 4. So 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths. I did it again all the way through 8. Remember, it's okay that it crosses over to the next one. I only had 2 tenths left. I can't act like those aren't there. I still have to use them. And then again, 8, 8, 8. Now I just count my groups of 8 tenths, and I end up with 1, 2, 3, 4, 5. Okay, now I'm going to show you standard algorithm with this one. Same thing. If your divisor is a decimal, you don't know your facts of decimals. They aren't as easy to think of as your facts of whole numbers. So you need to make that decimal a whole number. The way you do that is shifting your decimal place over or multiplying by 10. So here I multiplied 8/10 by 10 and you end up with 8. If you do it to the divisor, you have to do it to the dividend. So because I multiplied 8/10 by 10, I had to multiply 4 wholes by 10. 4 times 10 ultimately ends up giving you 40. Okay, now you can do how many times can 8 go into 4? It can't. You can represent it with a 0 or you can also leave it. How many times can 8 go into 40? Well, you know that 8 times 5 is actually 40, so 8 times 5, 40, we are left with nothing left over. And your answer would be 5 wholes. There are 5 whole 8/10 parts in the whole number 4. All right, we're going to stop there, but if you want to try this one on your own, you are welcome to.